In section 10.5, we're going to look at box and whisker plots. So you can see here I provided an example of a box and whisker plot. It is literally a box with whiskers coming off of it. So let's describe what a box and whisker plot is to start. It organizes data values into 4 groups, and you can see these groups again in the example. So here's group number 1. Group number 2 would be here from this side of the box to this line in the box. Group 3 would be here from this line to the end of the box, and then here would be group 4. Ordered data, meaning data that is in order, are divided into lower and upper halves by the median. So again, looking at our example, this is the median, so this would be the lower half, and this would be the upper half. The median of the lower half is the lower quartile. The median of the upper half is the upper quartile. So again, looking at our diagram, this number is your minimum number. This number is your maximum number. And as you can see, the minimum and the maximum is how the whiskers are drawn. So let's move on to the box. The box is formed by the lower quartile and the upper quartile. So again, you find the middle of the lower half and the middle of the upper half, and that's where the 2 lines for the outside of the boxes go. And the line in the middle or near the middle of the box is the median. So one more time, you'll start by putting your data in order. Find the median, that's the middle of your box. Then you're going to find the middle of the lower half, that's the lower quartile or the end of the box over here. Then you're going to find the middle of the upper quartile, which is the end of the box on this side. Draw the box around that and draw whiskers to the minimum and maximum numbers. Notice also that the box and whisker plot is plotted on a number line. So always have the number line set up first and then start drawing in your box and whisker plot. So let's look at an example of making a box and whisker plot. So here's example number 1. The prices in dollars of 27-inch television sets at an electronics store are given below. $188, $225, $192, $239, $271, $286, $224, $334, $316, and $275. The first thing they want us to do is find the median. In order to find the median, we're going to have to put our numbers in order from least to greatest. So let's do that first. So now that I have my numbers in order, I'm going to count inward. So there were 10 numbers, so that means I would have 5 on each side of the middle. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So right here is the middle. That means I have 2 middle numbers, so that's when I take both numbers, add them together, and divide by 2. So I would end up with 255 as the median. So now to find the lower quartile, that means the middle of the lower half. Since the median divides it in half, we're just looking at these numbers. So the middle number here, there's 1, 2, 3, 4, 5 numbers. So that means my third number in is the middle. So my lower quartile would be 224. And then for part C, for the upper quartile, again, I'm finding the middle of 5 numbers. So this number would be the middle. So the upper quartile is 286. So now for part D, when it says make a box and whisker plot of the television prices, remember we have to put this on a number line. So the hardest part here is just deciding how we're going to divide up the number line so that it's easy and convenient for us to place numbers on it. So what I do is look at my minimum and my maximum and decide off of that how I'm going to divide up my number line. So my lowest is 188, my highest is 334. So I'm thinking if I start at 180 and count by 20s, I could easily get up to 334. So 180, 200, 220, all the way up to 340. So now we're just going to place our numbers. So we start with our median. It was at 255. So we're going to go to our 255, which would be right about here, and we're going to put a line below that number line for the median. Then we're going to go to the lower quartile, which is 224. So that'd be right around here. So a line there. Remember that would be the end of the box. And then the upper quartile is 286. So that would be right around here. And that forms the box of the box and whisker. And then we put a dot at the minimum, which is 188, so that would be right about here. And a dot at the maximum, 334, which would be right about here. and then we just draw whiskers to the box from those dots. A lot of times they end up labeling these numbers as you go along so you can more visually see where the minimum, maximum, lower, and upper quartiles as well as the median, so that again you have more information on your box and whisker plot. So 188 right here, 224 right here, 255 for the median, 286 for the upper quartile, and 334 for the maximum. And that's how you make a box and whisker plot. So now let's interpret a box and whisker plot. So here again you see an example of a box and whisker plot. They started at 0 and went to 60 with their number line. So we have our minimum, our maximum, lower quartile, upper quartile, and the median. So it says that each whisker represents 25% of the data, because remember, a box and whisker plot splits your data up into 4 parts. So here's 25%, here would be 25%, this would be 25%, and this would be 25%. So the box on each side of the median represents about 25% of the data. So 25, 25, 25, 25. The interquartile range is the difference of the upper and lower quartiles. Basically, it's just the length of the box. And the way you can use a box and whisker plot to interpret your data is by looking at it with the percentages. If a whisker represents 25% and from the lower quartile to the median represents 25%, on this box and whisker plot, you would see that 50% of your data values lie between 0 and this median, which I would assume is around 12. So again, half of your data is all clustered within a very small portion of each other. So again, from 0 to 12. But then the other 50% goes from that 12 all the way up to, let's say that's probably around like 56 or 57. So 50% of your data is more spread out than your 50% over here that is more clustered together. So your data is more representative in this spot than in this spot, since this is more stretched out. So again, you can use box and whisker plots to interpret using all of the percentages that are represented within a box or whisker plot. So let's put that information to use. Here's example number 2. The box and whisker plots below show the normal monthly wind speeds in miles per hour in Athens and Savannah, Georgia. Part A says for how many months is Athens wind speed more than 8.3 miles per hour. So first, let's look at the Athens box and whisker plot. We see 8.3 right here. And the question is, for how many months is Athens wind speed more than 8.3 miles per hour? So that would be representative of this whisker right here. So knowing that a whisker represents 25% of your data, that means 25% of the year, the wind speed is more than 8.3 miles per hour. 25% of a year is 3 months. So for 3 months out of the year, the wind speed in Athens is more than 8.3 miles per hour. Part B says compare the wind speeds in the 2 cities. So if you look at just the length of the 2 box and whisker plots, in Athens it goes from 5.8 to 8.7, which is a difference of 2.9. But for Savannah, it goes from 6.7 to 9.1, which is a difference of 2.4. So what that means is we have more variance with the wind speeds in Athens than we do from Savannah, since we have a smaller distance that is covered with a box and whisker plot with Savannah. So again, the wind speeds vary more in Athens, but when you compare Athens to Savannah, you can see that Savannah's wind speeds are generally higher than the wind speeds in Athens, since its lowest is 6.7 and highest is 9.1, whereas in Athens, its lowest is 5.8 and its highest is 8.7. So again, the wind speeds vary more in Athens, but in general, wind speeds are stronger in Savannah. That's it for this section. Make sure you jot down anything you don't understand that we can cover in class before we move on, and we'll see you then.